Hello and welcome everyone. So this is one of the bonus sections that we're doing. Specifically, we're going to cover our targeting actor for our gameplay ability system. Remember, this is just one way of doing this, and we're going to start by creating a targeting actor in C++ and then extend it towards Blueprint to use it inside of our gameplay abilities. So to start off, just go to File and create a new C++ class, and this is going to have the type gameplay ability targeting, this one, target actor. Click next, and we're going to just rename this to GA target actor. So the name is a bit short. Create class, and while it's compiling, and we're going to return to the video after this is compiling is done. Okay, so once the Visual Studio has loaded, what we're going to do is open up our GA target actor header file, and first of all declare our scope as public. Okay, and next what we can do is actually define and declare our constructor over here. Okay, and next what we can do is actually override two functions that are provided by this gameplay ability target actor. First one is start targeting, so virtual void start targeting. Okay, it does take an argument. It's going to be u gameplay ability, and we're going to name this ability. We're going to override this. Another function we are going to override is confirm targeting and continue void, and it's going to be confirm targeting and continue. This doesn't take any arguments. Also going to override this. Okay, and next we're going to actually declare a blueprint exposed variable that we're going to set on spawn of this actor, and this is going to be, so this is going to be u property. I'm going to say edit anywhere. This is going to be blueprint read write, and we're going to also specify a meta for this, which is going to be expose on spawn, which is going to be true, and we're going to give the category of target actor. Okay, and we're just going to type float. We call this trace range. Okay, and next we're also going to declare a C++ function. This is not going to be exposed towards blueprint, but this is going to be used inside of this target actor for our line trace. So it's going to be bool line trace fn, and it's going to take an argument of hit results, and it's going to pass by reference, and I'm going to call this trace hit result. Okay, so our header file is done with the declarations. Now we're going to actually define these functions. First we're going to define our constructor. We're going to create an implementation for this inside of our CPP file. Inside of it, what I'm going to actually do is just initialize a few variables. First one is going to be primary actor tick dot began ever tick is equal to true. Primary, this one. Okay, next what I'm going to do is initialize our trace range variable to a default value of 1500 units. Okay, and last I'm going to initialize also a variable be destroy on confirmation. It's going to be true as well. Now this value is being provided to us by this target actor class, and we're going to set this value to true, so that this actually destroyed means one, we have confirmed our targeting. Okay, and now we're going to define the start targeting function. So what you see in this header file, if I go over here, we have our function, this start targeting. If I navigate over here, what it's doing is setting this owning ability equal to this ability. So this is what we're going to do in our class as well. Okay, and we're also going to add a few other variables, set a few other variables for this. So we're going to set our master PC as well, and master PC is also a variable that is provided by this gameplay ability target actor class. So we're going to set this to master PC is equal to cast. We're going to cast this to ability dot get owning actor from actor info, and we're going to we'll use this one and say get instigator controller. Okay, and we also need to pass this to a player controller, and I think it's missing a few header files. These are going to be all the header files. Okay, so it's going to be abilities, and it's going to be gameplay ability.h. Let's also include one for controller and pawn. So game framework, and it's going to be pawn.h. We need this pawn class as well. We need one for player controller, game framework, and so to be player controller.h. Okay, I think these are all the header files that we require for this, and this function is done as well. And next we're going to define this function confirm targeting and continue, create an implementation for this. Now if you see over here in our class confirm targeting and continue definition, what you see over here is that it's broadcasting an empty gameplay with target data header. What we're going to actually do is populate this target data header other than this empty value, and we're going to return our hit results from this confirm targeting and continue function. So what I do is over here is actually define this function a bit later. First I'm going to define this line trace function, because this is a function that we're going to use inside of our confirm targeting and continue. Over here what I'm going to do is define a few variables. First of all, so f vector is going to be viewpoint, and then f rotator is going to be view rotation. Okay, and then what I'm going to do is say master PC get player viewpoint, and this is going to take two arguments. It's going to be viewpoint and our view rotation. Okay, and next we're going to define a few variables for our line trace. So it's going to be f collision query parameters, and it's going to be called query params. Okay, and next we're going to say query params dot b trace complex is going to be false, and it's going to find our pawn. A pawn pointer is going to be called master pawn, because we want to ignore this in our line trace. So you can say master PC and get pawn. Okay, and then what you can do is say if master pawn is a valid thing, what you want to do is query params dot add ignored actors, and we're going to say this as master pawn dot get unique ID. Okay, and after this we're going to start our line trace. It's going to be bool try trace. I'm going to say get world, and from here we're going to say line, it's going to be this thing, line trace single by channel, this one, and it's going to take our arguments like trace hit result first of all. Then we require our start point, which is going to be our viewpoint, and our endpoint is going to be actually viewpoint plus we're going to say view rotation. We're going to get its vector, and what I'm going to do is actually multiply this by our trace range, and I'm going to do this for visibility channel, and I'm going to also pass in our query parameters. Okay, so once this is done, I'm going to return this value, return try trace. Okay, so this is done. Now we can use this function inside of our confirm targeting and continue function. So over here what I'm going to do is actually define another variable hit result, and I'm going to call this hit result. Okay, and next what I'm going to do is call that a function try trace. Line trace function is going to be line trace fn, is going to take our hit results as an argument, and next we're going to do is say f gameplay ability target data is going to be handled, and it's going to be called target data, and I'm going to set this value to target data is equal to start location dot and make target data handle from hit results, and it's going to be owning ability and trace hit results. Now the start location variable is also present inside of this target actor class. It's going to be this one, and this is of the type app gameplay ability target location info. So over here we are not actually using this variable as is, but we are using this class target location info to call this function, a member function, make target data handle from hit results, and set this equal to our target data. And just so you know, there could be a better way to do this, but let's stick to this for now. And what I'm going to do is say if target data is not equal to null pointer, then I'm going to do is broadcast this. So target data ready delegate dot broadcast, and it's going to be our target data. And if this is a null pointer, what I'm going to do is just broadcast an empty. So target data ready delegate dot broadcast, and what I'm going to do is broadcast an empty gameplay ability target data handle. Okay, so I think all of this is done. Another thing that I want to do is go to this build.cs file and add a new module over here as well. You might require this in the future, and it's going to be gameplay tasks. Okay, you may not need this for this specific example, but you may require this in the future, so this is here for those people. Okay, I think everything is ready, so let's go ahead and try to compile this. Okay, so our compilation is done, and let's go ahead and start our engine. Go to debug and start without debugging. Okay, so our engine has loaded up, and what I'm going to do is first of all change these possessions from our previous example. Disabled, and I'm going to use our player factor in this case, player 0. Open this up, and over here what I'm going to do is actually define a new input for this, and action mapping. I'm going to call this Q ability. I'm going to use the input Q for this. Okay, go back over here, and I'm going to define a new teleportation ability for this character. So go to abilities, create a new folder, and teleport. Okay, and create a new blueprint class of the type gameplay ability. I'm going to use this one. I'm going to call this GA teleport. Open this up, and I don't need these. So over here what I'm going to do is say commit ability, and then what I'm going to do is say wait target data. Okay, and for this class I'm going to use my class GA_target_actor. I'm going to change this to user confirmed, and now you see we have our trace range variable over here. We have other start location, rectal frame, but we're not using these for now. Okay, and what you could do also is create a blueprint class based off this and expose this variable over there and add some cosmetics. Like, let's do this just for the tutorial's sake. Public and GA_target_actor, right click on this, create blueprint class. We call this inside of our base classes. We call this VP_GA_target_actor. And now you see this is just like a regular actor. We have our targeting class information over here, extras, and we should have our variable, this trace range. You can set override the default value over here if you don't want to do it in C++. And over here we can use this VP_GA_target class as well. We haven't modified anything, so well it's going to work. And from this value data, what I'm going to do is say move to. I'm going to use this move to location ability task, and for the location what I'm going to actually do is drag out from here and say get hit result from target data, and I'm going to break this, break hit results. From here what I'm going to do is say drag out this location and say select this one, and the second option is going to be trace end. This is going to be our blocking hit. I'm going to return this value over here, and for the duration I'm going to just keep it at 0, so it's an instantaneous teleport. And once this is done, I'm going to say end ability. Okay, and if the ability is targeting is cancelled, so I'm going to say end ability as well over here. And I think this is it for our ability. You can add your tags, cooldown and cost over here, but just to keep it simple, I'm going to do it like this. Yep, this is done. And next what I'm going to do is also give this ability inside of our player character. So over here I'm going to add a new variable and call this teleport, GA_teleport. Okay, and I'm also going to use our best Q ability input. Over here what I'm going to do is say try activate ability by class, and for the class I'm going to select our teleport, and to confirm our targeting what I'm going to do is define our left mouse button as our targeting input. What I'm going to say is left mouse button. Over here I'm going to drag out and say confirm target. I think it's from this one, target confirm this one. And what I could actually do is on my right mouse button I could say cancel target, this one target cancel. Okay, so if I confirm a target I'm going to teleport to a location, and if I cancel my target I'm going to cancel or end my ability without teleporting to this location. Compile this. So there was a bit of an error. What we want to actually do is plug this location to true and trace end to false. So if we are blocking, we go to our blocking location, and if this is false, then we go to the maximum range for our trace. I'll compile and save this. Plus I also adjusted our camera to be a little bit off the shoulder. Just use these values, y equal to 80 and z equal to 50 for the socket offset of the camera boom. And now what you should see is that if I press my Q key, my ability is ready, and if I press my left mouse button, I'm teleporting to a location. Press the Q, press the left mouse button, I'm teleporting. Okay, so this is it. And if you see, just to visualize our cancelling, what I'm going to actually do is on end ability, I'm going to say print a string and say ability ended. Okay, and what you should see now is if I press my Q key and press my right mouse button, it's going to say ability ended, and I've done this without teleporting to the location. If I press the Q key again and press my left mouse button, I teleport to the location and end my ability. So this is how you use your targeting inside of your gameplay ability system, and this is just one way of doing this. If you drag out from this data, you will see get actors from target data as well. You can return some overlapping actors for your area of effect kind of abilities. If you want to cast a spell over an area, you could use this. But you do need to do this work inside of your C++. There is a function under the start location. If you see start location dot make target data handler from actors and for multiple hit results, you could use these functions if you want to, but these things have to be done inside of C++. If this is too difficult for you, just stick to this line trace function and use this function to spawn an actor. Or you could actually do is for example, say sphere overlap actors from your blueprints, and just plug this in over here and specify a radius like 500 for example, and this would give you the actors that have overlapped if you don't want to do this inside of C++. Okay, and there's also this rectile parameters and rectile class just to visualize where you are targeting. I couldn't get this to work, but there are a few examples that you can use to get this working for your SEP or for your game. Gas Shooter is an excellent example to view for this rectile parameters. So yeah, I think this is it for this video, and in the next video what we're going to do is actually deal with our damage execution calculations for our armor and health example. So this is it for this video. Thank you very much.